Page 30, question 14. This is on sound, which is under your wave. So now we have two sound, P and Q. P actually has a higher amplitude, has a larger amplitude. So amplitude is linked to loudness. Therefore, P is louder. Okay. How about higher pitch? Pitch is linked to frequency. The higher the frequency, the higher the pitch. So that means it must make more wave per unit time. There must be more wave. So Q actually has more complete wave. Therefore, Q is the sound with higher pitch. So answer is B. The trick here is because it vibrates back and forward 96000 times per minute. Per minute, what do you need to do? You need to change it to per second. So it will be 96000 over 60. So it will be 1600 times per second. Number of times that something happened is called frequency. So the unit for frequency is hertz. And because the speed of sound is 320, is 320 meter per second, so this is my V. So the formula to use is V equals to F lambda, 320 equals to 1600. Then they are asking us to find wavelength, which is actually lambda. So lambda will then be 320 divided by 1600. So I guess the answer will be B, right? So are we okay? Okay, it represents a sound wave. The wave change from X to Y. Okay, so for X, maybe we see for this square, how many times it complete one wave? 1, 2, 3, 4. Okay, then we check for this square here. 1, 2, 3, 4. So in both cases, the timing is the same. The timing is the same, right? And the number of waves completed, waves is 4. Similar to this. So the number of waves completed means the frequency. Okay, if let's say this takes 1 second, the frequency is 4 hertz. Example, but I'm not sure if this is 1 second. I just assume it to be 1 second, right? So if it's 1 second, the frequency will be 4 hertz. If it's 1 minute, then you have to convert this minute to seconds. So the frequency is the same. How about the amplitude? Amplitude, is it from here to here or here to here? A or B? A, So this is actually, yes. So the amplitude of the wave is actually decreasing. Okay, it is actually decreasing. How about the frequency? It is constant. Frequency is constant, same. So the pitch is increasing, also false, because pitch is linked to frequency. And if frequency, there's no change, therefore the pitch should be constant. How about the volume? Volume is linked to loudness. Okay, so therefore D is the correct answer. Okay. Displacement time graph, what can we get from the displacement axis? Nope. We can get amplitude. So the amplitude is from crest to rest. Crest position to rest position. Okay, so just now actually when I was asking you about the amplitude, right, whether is it the full length or half of it, I forgot a little bit. So I hesitated. Then I remember, amplitude is always from crest, the highest point, to rest. And they rhyme. So this is my amplitude. What can we get from the time axis? What can we get from the time axis? We can get the period. And once we know the period, we can get the frequency. So the amplitude is actually 10 cm. Do you all agree? Without even looking at the question, if they were to present a displacement time graph, You read the graph, you should get all this information. Amplitude is 10 cm. How about the period? From we start at 2 seconds. Tell me when is a complete wave. Here. So this is a complete wave. So 4 minus 2, the period is 2 seconds. So this is my period. Now, period and frequency is linked by this formula. Therefore, the frequency is 0.5 Hertz. Are we okay? Then now all we need to do is choose the correct option. After that, F equals to 0.5. Okay? Okay, so V equals F lambda. So all I can use for this question is 0.5 Hertz. That means my V equals to 0.5 lambda. That means my V over lambda must be equal to 0.5. So now I need to choose every option. I need to take the V divided by the lambda to see if it matches 0.5. If it matches, that is the correct option. So the only one that is correct is C, right? Answer is C, right? So you still have to do some guess and check. But it is not difficult, just very troublesome and irritating. Okay? What can you get from displacement? Distance. What can you get? Displacement distance, you can also get amplitude from displacement. What can you get from the distance part? Very good. Okay? You can get wavelength. So please take note of this. Once they show these two graphs, you know you can score already if you memorize this. Alright?